original main method where we got two values, we calculated the mark and we outputted the mark. Now we want a more sophisticated way of making many decisions. And what I mean by that is you need to be able to say, well, if it's over 70, then you got a first. If it's between these two grades, it's a 2-1. If it's these two grades, it's a 2-2, and so on, right down to a fail. How do you turn something like this, with these multiple possibilities, into code? Well, let's have a look at that. And in this video, I'm deliberately going to keep the complexity down to a minimum because it is realistically a lot more complicated to work it out from scratch. So in this video, what I'd like you to do is follow what I do, copy it, and follow the reasoning process and how we are doing it. So we've got an if statement here, and we want to say the module mark. If the module mark is greater than or equal to 70, then we are going to print first. Now, the next condition is, now I'm deliberately going to mistype this because I want you to have a look at how you actually bind all these conditions together. What I'm going to do is, and I'm going to do this quickly and you should do the same. I'm going to do one for 60. So this is the 60 to 69 range, and that's a 2-1. And actually that's incomplete. It should be greater than thing, but we'll come back to that in one moment. Do one for 50. We are going to do one for 40. And perhaps one other, but that'll do for the time being. Okay, so have a look at this. If it's above 60, it's a 2-1. Above 50, it's a 2-2. Above 40, it's a third. And if it's less than 40, it's a fail. Okay, so let's have a look at what we've written here. We've separated out all these possible conditions. And in theory, you know, this is us trying to translate the logic that we said here that we wanted to use. And the question is this the right way of coding it? Now, what I'm going to do is just pause for a second. And I'm going to ask you to code what we have. And the reason that I'm going to ask you to code it is because I want you to see the demonstration and the effect. Now, technically, you might straight away say that's not the same as that 60 to 69. Surely I need to put that in that condition. I need to say, well, if it's greater than 60 and the module mark is less than or equal to 69, surely that's a better copy of the condition. So let's put that all the way in, and we'll tidy it all in. Notice I'm using a little bit of copying and pasting and just changing values. That goes from 69 to 59. That goes to 49. Now that looks a lot more like our initial problem, which stated that if the grade was greater than 70, it's a first. If it's between those two values, it's a 2-1. If it's between those two, etc., etc. Notice how I write it. If the module is greater than 60 and the module both have to be true for it to be a 2-1. Both of those have to be true for a 2-2. Both of those have to be true for a third, and it has to be less than 40 for a fail. Now that is a multiple if statement, a multiple set of conditions. Each one is an if. But look how complicated each one is. Each one stands independently, and you have to give it, supply it the full condition in order to write that. So you have to use this and word because you're saying both that and that. Both that and that do that. Both that and that. Okay? Now, superficially, that should solve our problem. Let's have a look. And what I want to introduce is a neater and a simpler way of doing this, because very few people actually code in this way. If the test mark, we're going to make it add up to around 55. So if we say 25 and 30, it comes back with a 2-2, which is correct. But here's the overhead, and this is the thing that as a new programmer you won't spot. Truthfully, if your grade was, say, 73, okay, then really all you want to do is, as soon as you answer that question, you don't want to do the rest of them because none of them are relevant. But the way that I've written it here with just a separate if statement, what it means is it treats each of them separately. So it actually has to ask each of them, which becomes a huge waste and an overhead and actually makes the code more complicated. What I want to do is I want to say it like this. Well, look, if your grade you enter is 73, then that's true. So then you don't need these. We skip over the rest of these. So how do I do that where it's only one or the other option, right? It's an exclusive condition. Well, we have to use else. Now, in Java, in Python language, we use elif. Now, before I explain what elif, it's easier if I just handwrite something for you to show you. So that was an earlier attempt to do it on a video that didn't quite work. If I say if da 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 do this, but then I want to say otherwise or else, if this is true, then do this. Okay, don't do this bit here if that's true. By using the word else, I bind them together, but Python doesn't use else and if. It compresses else and if into a single word called elif. A bit like an elf, a bit like Lord of the Rings, for those of you who know that. So look back here. I'm saying if that's true, then do that. Otherwise, if that's true, do that. Otherwise, and on we go. So I just stick an L in front of every single one of these if statements, and then we ask whether we have it sorted out. So, and that looks better, right? That means that if that condition is true, it will actually skip all these others because of this else if presence. But here's the question. Do I need to have that bit in the statement anymore? Is somehow this whole structure built in a way that simplifies these individual questions? Simple answer is yes. Think about it. If I ask if it's over 70, so say you entered 73, okay, it would just execute that print and then it would skip the rest because they're all else ifs or elifs. So I don't need to say it's got to be less for that, because this question is always connected. These questions are always connected to the previous if statement. They're all linked together. And in fact, when you go over and equal to 40, you don't even need to say if here anymore. For the very last condition, you can just use the word else. So have a look how much simpler that is. By using this else if or elif, and then right at the end sticking an else in, I can simplify how I write it. That's one advantage. The second advantage is that this is dependent on this initial condition being false. So if this is true, you go there. If it's false, I will go here and ask this question. But if this is true, it does that and doesn't go to any of the others. So it links them all together. Now that's a lot to take in initially. What you need to take away from here is A, you should code that yourself. We'll test it in a second. But we can combine these conditions and different questions in this kind of way. And by combining them in this kind of way, you simplify and you logically strengthen your code base. You don't necessarily have to keep on asking the question, well, if it's over 70, oh, what happens if it's over 60? It's irrelevant. If that one is true, the rest of them are irrelevant. And that saves an overhead. Let's try one in the 50s, right? 34 and let's say 24. It's a 2-2. Now, if I could go step by step through the code, the way that it would have arrived at that 2-2 more efficiently, it would have asked that question, that's false, it isn't over that. So it would have asked that question, that's false. It would have asked that question, oh, that's true. Prints that, but because that's true, it then skips the rest. If these were separate if statements, it doesn't matter if each if statement is true, it would still have to do it all. So just to quickly jump backwards and undo those changes. So when we had that version, it didn't matter that that was true because this is treated as a separate statement. They're not bound together in any way. And so if I can just redo, see what the redo is, Shift Y. By binding them together into a single complex and stripping out some of the extra text, you turn it into a much tighter, logical and clearer logical setup.